Hello everyone. In this video, we'll discuss some more fundamental concepts in the basics of flat plotting. Okay. So I just want to plot a graph. Okay. Kinetic energy versus velocity. Okay. We know that kinetic energy is of mv square. Okay. I want to plot this velocity. So the velocity range is 10 to 100. Okay, I need to increase the step size by 10. So let me take mass 250 kilograms. Okay, let me take mass as 250 kilograms. Okay, so in order to generate values from 10 to 100, I'm just using linspace. Okay, the starting index is 10, end index is 110. The increment is totally 10 samples. I'm just taking 10 samples. Okay, start index, stop index, the total number of samples 10. Okay, so let me plot this. We know that the unit for velocity is meter per second. Let me include that in the x label. Similarly, the unit for kinetic energy is joule. Let me include that in the y label. Okay. Okay, I don't want all these things. Comment this part. Okay. Linspace 10 to 110, totally 10 data points. Okay, totally 10 data points. Okay, I have the velocity something like this. Now I need to plot. Okay, I need to plot x comma, or instead of x, let me give v of velocity. So x axis it is velocity, y axis 1 by 2 m. Okay, m v square, okay, double star 2. I need to define m is 2. Okay, I think it is done. We close the previous figures. Yeah, so now let me add x label, y label. X label, it is velocity, the unit is meter per second. Okay, y label, okay, is kinetic energy in joules. Okay, x label velocity meter per second, y label kinetic energy joules. We just see whatever we have typed, that is available. Kinetic energy joules, velocity meter per second. Okay. See now I just want to change the color of x label and y label. So you can use color. Okay, you can give different colors. Let me use green color for x axis and red color for y axis. Okay, we add color, green color for x axis, red color for y axis. Okay, execute. You just see green color for x axis, red color for your y axis. Okay, then you can also increase the font size of this x label and y label. Okay, that is also available. So what you can do, you can additionally go for font size. Let me use 14. Okay, just to show the difference, For one X label I'm just using the font size, whereas Y label I'm not using. Okay. You just see here it is small, here it is big. Font size has been increased. Okay, font size has been increased. Then we will discuss this text box. Okay, text is similar to annotation. So I want to add the text S. Okay, I want to add the text S in the given XY location. Okay, so you need to support XY. Okay, and the string. Okay, you can also give the font size. For example, for 40. Okay, for 40 on this particular point, Y axis. Okay, this particular point, I want to write kinetic energy versus velocity. Okay, with a font size of 12. Okay, so what I'm doing, I'm just using text. X is 40. Okay, Y is 12. 1, 2, 3, 4, 5. Okay, what is the string I want to write? Kinetic energy versus velocity. Okay, velocity. Let me check whether it is working. Yeah, it is working. Okay, it is working. I want to increase the font size. Let me test that also. Let me give font size is equal to 14. Okay. Yeah, let me close the figure. Overwrites. Just see the font size has increased. Okay, the font size has increased. There is an additional feature for this text. Okay, so if I add this V box, okay, if I add this particular V box, what happens? You can see that particular text or the string that appears within the box with the given color. So here I have given red color, okay, and some contrast adjustment 0. Okay, so this also you can try V box. V box is equal to dictionary, PIC, dictionary. Face color is equal to face color. Let me try this. Again it overwrites. Let me close the figure window. You just see with red color it is coming. Okay, with red color it is plotted. Here again you can go for different colors. You can adjust I can go see here I have went for blue color. Okay, all these things you can try. If I reduce alpha, see the color is dominating and the letters are not clear. Okay, those things you can play. Then I want to plot a DC voltage versus time. Okay, for example, minus 10 to plus 10. I'm just taking 100 data samples. Okay, we know the DC voltage, it is constant. Okay, it should be 5 volt. So let me try this particular thing. So first let me change these things. It's not velocity. Let me give this as time. Minus 10 to plus 10. Totally there are 100. Okay, 100 samples. I'm going to plot t, 5. Okay, for all the time period it is 5. Okay, let me comment this xlabel, ylabel, text, all those things. Let's see this. See, it is showing a error. What is the error means? X and y must have the same dimension. X is the vector whereas y is the scalar. So because of that the error is coming. Okay. So what you can do in the linspace, you can give the starting index 5, end index 5. Okay. You can generate 100 samples. So all the values are 5 only. It generates 100 samples with the same value 5. Okay. Let us try that. So I'm using another linspace. Let me call this as DC or something. Okay. From starting value 5, end value 5. I'm going to plot T comma DC. Okay. If we close the previous figure, we execute this. You just see it is constant. Okay. In the command window, if I type DC, you just see all the values of 5. Okay. It generates totally 100 values of 5. Length of DC. Okay. So already we discussed about subplot. Okay. I'll stop here. We discussed some of the fundamentals like how to, if you have a DC value, if you have a constant value, but you want to match it to the length of the x-axis, what we can do. Then what is the text box? Okay. Then we discussed how to change the color and font size of xlabel, ylabel. Okay. I'll stop here. Thank you.